Hey everybody, Dr. Phil here. So this is going to be a video where I discuss databases in the context of MIS, Management Information Systems. So first thing I want to talk about is what we call database management systems, sometimes abbreviated DBMSs. So this is a computer program that is used to create, process, and administer a database. Due to the complexities surrounding the DBMS development process, most organizations do not develop their own database management systems. They typically will just buy it from somebody else. A big company might decide to do that in-house with the help of consultants, but mostly they're not doing that. They're just going to buy it from somebody else. So then you might say, so who would they buy it from? Then that would be, you may have heard of like SAP, you may have heard of Oracle is mentioned at the bottom there. Microsoft certainly does it. IBM, International Business Machines, all these firms do it. So it's important to note the differences between a database and a DBMS, a database management system, because there's a lot of confusion, consternation between these two. So a database is a collection of tables, relationships, and metadata. DBMSs helps to organize the data found in a database. Now, a DBMS is a software program, as we said, designed to organize and administer a database. So think of the database as just like the raw, collection repository of the data. The DBMS is how we're going to organize it. Data integrity. So this means the database is reliable, accurate, and aligned to the goals of the organization. Data centralization is critical in increasing data integrity. When data is centralized, it means it's stored in only one place. So we're sort of trying to eliminate redundancy here. When multiple lists and data sources are maintained, information can become inconsistent, leading to decreased data integrity. Now, relational databases, these organize data into tables based on structured data groupings. Relational databases use links called relationships between tables. So tables, just think of like a regular table. Tables are used to hold information about the objects to be represented in the database. Information in tables is stored in rows called records or objects, and columns called fields. These relationships define how the data in the table are related. A common field that's included in both tables is used to create the relationship. So there's going to be something between the two that they have in common, that's in both. Rows among multiple tables can be made related using what we call foreign keys. Data can be accessed in many different ways without reorganizing the database tables themselves. So what is a query? So think of a query as, a query is a question, right? So if you're querying a database, you're basically trying to find something out of value, basically trying to turn like data into information. So a query is, as we say, is known as a question. Queries request information from a table or combination of tables in a database. SQL, structured query language, is one of the most popular query languages used in creating queries. Queries allow you to find specific data quickly by filtering based on specific criteria, calculate summarized data, and automate data management tasks. And with respect to entity relationship diagrams and ER modeling, entity relationship diagrams are used in the design of relational databases to visually represent the relationships between different data entities, and they are composed of three main elements. So first, of course, is the entities. They're typically represented by rectangles. Relationships are represented by lines that connect the entities, and attributes, often included in a rectangle, representing the entity. Now, entities represent objects or occurrences. In databases, entities are typically entered into tables. They have two characteristics, and they are often nouns, so think of like naming words. Relationships describe how entities interact with each other, are frequently represented as verbs, so think about like a verb, like a doing word. And in relational databases, they're categorized, as one-to-one, one-to-many, or many-to-many. So with respect to attributes, attributes are data points that are stored for each entity. Attributes can be identified as either primary or foreign keys. A primary key is a unique identifier for each instance of an entity. So for example, if we look at the students table here, the student ID, that would be the primary key because of course that is a unique identifier. You wouldn't use name like first or last name because there might be more than one student there with that same first or last name. Whereas a student ID, just like somebody's social security number would directly identify them, right? A foreign key links a primary key to a column in a different table in a database. So SQL, structured query language. So SQL is used for human interface and communication with relational databases. It's considered the standard language. So SQL uses user-generated lines of code, which we call statements, to answer questions against the database. Most relational databases use SQL, but most also have proprietary extensions that allow for customized interactivity. So maybe something more unique to a particular company, for example. So what is big data? That's a term that we always, we hear a lot of these days. So big data encompasses all of the analysis tools and processes related to applying and managing large volumes of data. So why big data? Big data was conceived out of the need of organizations to better understand trends, patterns, and preferences that emerge from the interaction with different systems and databases. So how does big data help? Big data allows organizations to use analytics to help uncover a variety of predictive behaviors to help create new offerings. So the four common characteristics of big data, and we're going to talk about them, each of these in more detail in a second, include number one, volume, number two, variety, number three, veracity, and number four, velocity. So the four V's of big data. So the first is volume. So think about the scale of the data. So enormous amounts of data are created every day, as I'm sure you're aware. Most companies have over 120 terabytes of information stored, which is just an incomprehensible amount, just astronomical amount. Next one is variety. So think about the different forms of data that these firms are storing. Data comes from many structured and unstructured sources. These sources include social media platforms, email, photos, videos, and point-of-sale interactions. The veracity speaks to the uncertainty of the data. With all of the data being generated and stored, it's important to ensure that data is meaningful and useful. Otherwise, why are we storing it? Why are they storing it? And then finally, velocity, the analysis of streaming data. The pace at which data is generated is mind-blowing. 90% of the data on the internet has been created since 2016. So just, almost a decade. Okay, let's talk now about business intelligence, often abbreviated BI. So when you hear BI, think about business intelligence. So these include the technologies, computer applications, and procedures for the collection, analysis, and presentation of business information to help support decision making. The key ideas here are fundamentally business intelligence systems are data-driven, and DSSs, think about decision support systems, that aid businesses to make better strategic decisions. Business intelligence systems, BI systems, provide businesses a picture of historic, current, and future views of operations. And BI systems use information stored in data warehouses, data marts, in-memory computing, and other analytic platforms to create information outputs. This is probably a term you've heard of before, a data warehouse. So a data warehouse is a repository of data and information that organizations analyze to make informed business and operational decisions. Data and the analytics provided from the analysis of data allow organizations to create and maintain a competitive advantage. Now think about the name data mart. Whereas data warehouses are considered multi-purpose data and information storage facilities, a data mart is a subsection of a data warehouse that's designed and built specifically for individual departments or business functions. So, for example, marketing could have their own data mart. Accounting could have their own data mart. So, finance could have their own data mart. So, a dependent data mart is constructed from existing data warehouses and utilizes a top-down approach where organizational data is stored in a centralized location. Then, specific data is extracted when analysis is such needed. An independent data mart is a standalone system that's created separate from a data warehouse and focuses on specific organizational functions. A hybrid data mart assimilates data from a data warehouse as well as other data collection systems. Now, what about data mining? This is also referred to as knowledge discovery in data, sometimes abbreviated KDD. This is searching of large data stores and sets to uncover patterns and trends that cannot be executed using OLAP or simple analysis techniques. The four key properties of data mining include number one, automatic discovery of patterns, number two, prediction of likely outcomes, number three, creation of actionable information, and number four, focus on large data sets and databases. This is a very popular position in most firms, including on most university campuses, what we call a data administrator or a database administrator, a DBA. So this is a technically specific role that's usually part of an organization's IT department. Database administrators monitor and troubleshoot when necessary the database to ensure it's functional and available when needed. And finally, best practices in database administration and maintenance. Database administrators are responsible for a variety of tasks designed to ensure that database management systems run securely and efficiently. Best practices for database and administration include obviously frequently backing it up. Number two, database monitoring. Number three, security, making sure no one's hacking the database, no unauthorized intrusions, etc. Number four, performance optimization. And finally, number five, data quality. And data quality is so important because if the database is, if there's a lot of data in there, but 90% of it is, is useless, it's wrong, it's erroneous, it's out of date, then, the value of the database can be called into question. Right, that's it for this video. Thanks as always for watching, and I will see you all in a future video. Take care.